Thank you very much for that awesome intro. Today I want to talk a little bit about building strong code through patterns. And I'm going to start off by saying I am a game developer, so all the examples you're going to see are taken from the game world. But all of these things can kind of be taken out and put into all different types of software practicing. So I don't have much time, and I really want to get through as much as I can here, because this is I can't go too deep because it's only like a 30-minute, 40-minute talk, so we'll try to get through as fast as we can. So here's the problem. Broken code, right? Broken, unstable, hard to manage, just a messy code base, right? Games and software lately have been being shipped out with huge game stopper bugs, showstopper bugs, right? You put up your hand if you've experienced this in like the last few months, right? Does it not feel like it's getting a little bit worse? Right, and I think a lot of this has to do with the fact that we're just trying to get things done, right? We're just trying to get things done, get it out the door, make the money we need to make, right? So, I know when I'm building my projects, I start out thinking of this grand plan, right? I have this thought in my head, like all my code's gonna plug together much like a Lego block creation from my youth, right? So, I start out, I'm like, okay, I'm gonna build all this, everything's gonna interconnect, it's all gonna work out really well. I'm probably not the only one. I'm sure you guys like to think that we all create masterpieces, right? Unfortunately, what we usually end up is this, right? We end up with a mess. I had to get it done, tangled code, where if you literally poked at it, everything's going to collapse, right? Let's be honest. I'm sure a lot of us are the reason that there's this code in the world, right? I know I've done this my fair share as well. And I understand there's a lot of outside forces, right? You've got things like technology restraints, you've got deadlines, varying skills amongst the team, right? You might have your junior programmers, junior senior programmers. So it's very easy to have this happen. But the problem with this is it's not just a bad code base because it causes bugs and errors and stuff like that, but it's also very incredibly expensive to maintain. Just think back for a few minutes. How long have you spent, how many hours you've wasted working your way through some tangled code, right? That's just a lot of time, and it's an expensive thing to go through. So what's the solution? Well, besides testing, and if you're not doing system testing or unit testing, for the love of God, start doing it. It's very important. This is how you're going to catch the bugs before you ship it out, and someone pays $60 for your game and then has it break the first time they install it. So make sure you're doing some sort of testing. That's key. But for our purposes, the solution is literally build better code, right? At the end of the day, that's what it boils down to. Now, I understand this is a hard thing to do, just build better code, right? Just build better modular code. But I truly think that you can do this, we can accomplish this through good software architecture, right? So my goal for the day is to really get you to think about how you can go through this process of creating good software architecture that is going to pay off in the long run, right? You know, when you're trying to find these bugs and everything. So I'm not going to go too deep on the patterns themselves specifically, but we're going to talk a little bit about why we use these patterns. So what is the definition of good software architecture? Well, to me, it's basically this: being able to add my Lego block without bringing the house down around it, right? So if I get into your code base, I want to be able to add what I'm working on without everything falling apart, right? Good software architecture basically boils down to how you organize your code, right? All code has some sort of organization to it, even if it's just jam everything into one main file and pray that it works, right? Code is consistently changing. If it's not changing, why are you working on it, right? How your code base reacts to these changes and how it performs with these changes is kind of the measurement for how good of a software architecture you have, right? So like I said, one way to accomplish this is through using design patterns. So this idea of design patterns, this whole philosophy, really solidified itself when I read this book. Design Patterns, Elements of Reusable Object-Oriented Software. Put your hand up if you've read this book. So a few. Okay. It's getting a little dated now, but the content is still excellent. It was written by a group of guys that have come to be known as the Gang of Four. And the book is basically divided into two parts. The first parts kind of go through the pitfalls and the uses of object-oriented programming. But the remaining chapters go through I think with 20 some odd different software design patterns, right? And they kind of walk you through the principles of why you want to use these patterns and stuff. So that's kind of where I got this mentality of the patterns from. So what is a pattern? Well, simply stated, a design pattern is a general reusable solution to a commonly occurring problem, right? It's a description or a template of how to solve a problem that can be used in many different situations. So you might find a solution that works for one situation, but if you turn it to formulate it into a pattern, you're able to use it throughout other software projects for similar type situations, right? Basically, patterns are formalized best practices that programmers can use to solve problems when designing their applications or systems. The big thing about patterns is patterns allow us to build your code strong, performant, adaptable, and a lot easier to work with. So our agenda, basically what we're going to walk through here, is I want to spend some time looking at decoupling code with a pattern. So one of the biggest things about patterns is the ability to decouple code, and we'll get into that in just in a second. As well as I want to take a look at how patterns can help with performance issues. Especially coming from the gaming world, a lot of the issues that I run into when I'm talking to developers are performance issues. So we'll take a look at how patterns can kind of help with that. And of course, for the decoupling, we'll take a look at the state pattern, specifically finite states. And we'll take a look at Flyweight for performance. And finally, everything's not rosy in the world of patterns, don't get me wrong. There are times, and you've probably heard this many times, everything in moderation. So we're going to take a look at the Singleton and kind of how patterns can have a dark side. So getting started with decoupling. So patterns help us decouple our code. So decoupling can be defined a variety of different ways, but I think it's fair enough to say that if two pieces of code are coupled together, they basically if you make a change to one, you have to make a change to the other, right? So if you want to work on something, you have to reason about this part and then reason about this part before you can actually get that change. That's coupled code. So by decoupling code, we're basically saying we don't need to reason about both pieces of code, just one while we're working on it, right? So this allows us to make changes to the overall code base, but making small impact on the entire setup, right? So if I want to change one small thing, I don't end up pulling the car that brings the house down, right? By decoupling it, that allows us to have that. It also helps isolate and make it easier to handle bugs, right? So if your code's decoupled and you have a bug, it's easier to find where that bug is because it's isolated to that one piece, that one chunk of code, right? So you can work on it and not have to worry about what does this bug mean to the rest of my code, right? It also speeds up coding because obviously it makes it easier to understand. If I'm the new junior programmer coming in, right, and I've got to learn this monolithic project, if it's all decoupled in chunks, it's easy for me just to look at the chunk that I need to work on, digest that, and jump right in. I don't need to sit there and spend hours and days trying to figure out what the program does. Okay, so let's take a look at the state pattern, more specifically finite state machines. The state pattern itself is absolutely huge. There's a lot of different facets to it, and we obviously don't have a time to go through it all. But the one I want to take a look at is finite state machines. So here's the problem, the Mario input problem. So the first time I really had a chance to see why I would want to use an SFM or a state pattern in general was my very first project in school. I was told, remake a level in Mario. Okay, fair enough, right? So I built my framework, I got my level all up, I added my Mario sprite, got him to move around, and then I'm like, okay, I've got to start working on my input, right? So first thing I did was add a jump. So this is the code for my jump, right? Got my input, I take it in input, I check to see if it matches my jump. If it does, I add some velocity and change some frames. Very, very simple. One giant bug right off the bat. Anybody know what that is? Any game developers in the room? Oh, not so many game developers, okay. We got one. Okay, so this is a common issue, especially for game developers when they're first starting out working with input. What happens right now is if I was to jump, there's nothing from stopping me from jumping again. So I could infinitely air jump, which may be cool for the user, but not so cool for me, right? So, Mario's just going to keep floating through the air. So, okay, not a big deal. We can fix that with the conditional, right? We check it with an if. So the code becomes this, right? So we have our input, we check to see if it's jumping. I have a Boolean that says, am I jumping? If it's set to false, right, then I can set it to true. And of course, I'll have code in here that'll set it to false when I look on the ground, right? Just cutting it out for the sake of doing that. So, okay, fine. Jumping's handled. I can double jump again. Perfect. So now I want to move on to adding some more input. So Mario can duck, right? So we should have a ducking function and the ability to duck and be able to stand back up. So for the code for that would look something like this. So it would come in, it would do a check to see if I'm jumping, it would do all that stuff that we just saw. And then it would do a check to see if I'm ducking. So if I'm ducking and I'm not jumping, go ahead and set this animation to the duck, whatever it might be. And then I also have one for release. Anybody spot the bug that I just added? So what's happening here is I can duck when I'm not jumping, but if I'm duck and in the air, if I press or release the duck button, he's going to stand up. Not exactly the outcome you want from Mario. So, okay, fine. I go back in, I add another conditional, I do another check, right? But all I'm doing here is basically, I have to add an attack command, add a power up, right, for when he grows, when he fires fireballs, all this stuff. This is just a basic sprite sheet, but I have to include states for every one of these, right? The problem is every time I add one, I have to add another conditional, and chances are I'm adding a bug in doing it, right? So you can see how this quickly becomes a giant mess of just if else, right? There's got to be a better way. So enter the FITC. So what the finite state machine basically gives us is, first of all, it gives us the ability to have a fixed set of states. So in our case, that would be, jumping, standing, ducking, walking, whatever it might be. The machine can only be in one state at a time. Well, this is huge for us because, like I said, I didn't want to be able to the ability to stand up while I'm in the middle of my jump. So this pattern right there is already constraining my code and not allowing it to do that. So it's removing that one set of bugs already. Another thing that it does is it has a sequence of inputs or events. For example, our button presses and releases are coming in, right? And we can do things based on that. For instance, each state has a set of transitions. So we can transition from state to state depending on our input. So the input comes in and we can transition between it, right? There's a lot of ways to do FFM, a lot. And there's a lot of complicated ones, but the one I really want to show you is probably the simplest way to implement this. And because basically I just want to get your toes wet and demonstrate how a pattern can kind of decouple and help you out. So we start off with this. We have our enum of Mario states. Everyone knows what enum is, I'm guessing. Right? It's a data type of objects or elements listed in plain English so that I don't have to worry about what number they are. So what we're doing here is we're saying, okay, we're going to have these states. We're going to have idle, we're going to have jumping, we're going to have ducking. Then, based on these states, we're going to build a switch case system. So we're going to switch based on our current state. So we'll have a variable that holds the state that we're currently in. So what happens here is we have our input stream coming in, right, and we're going to check for our triggers. So our first case is Mario.idle, right? So this is when Mario's idling. If the input comes in and it matches, and we're already in our idle state, and it matches jump, we're going to switch to our jumping state. Simple enough, no? We'll do, all the fancy stuff to make him look cool when he's jumping. Other than that, if we're in our idle and we press the duck, we're going to switch to the ducking. So right there, we've taken care of jumping. So if I press the jump button, he'll do his little jump and he'll transition into his jumping state. If I press the duck, he'll do his little animation and be in the ducking state. So, of course, we have our jumping, which asks us, or says if the input coming in is ducked, right, is the ducking, then switch to our ducking. Otherwise, if we're in ducking state and the ducking's released, go back to idle. Does that all make kind of sense? Basically, what we're doing here is we're just using a switch case. Very, very simple programming trick that we probably all use in some regard, right? But basically what we're doing here is we're building it out into a finite state machine and decoupling our code. So what happens is if I come along and I'm like, okay, I want to add an attack command now. Well, all I have to do is add a new state, right, in my enum for attacking, and then add another case. Even if I add a bug to that case, it's not going to affect my other cases. I'm still going to be able to jump just right. I'm still going to be able to duck. I'm still going to be able to do all those things. So you can see why decoupling your code with something as simple as just a finite state machine, and all it really is an enum and a switch case, can really help us out as we're going forward. You're going to be able to, you'll find that the bugs that are occurring are in the new code that you're writing and not cascading down the road, right? Okay, so a little bit about why you would want to decouple and how you can kind of decouple with patterns. I got flash to find, so we'll try to speed up here. Performance. Another big reason why you want to use patterns, right? You can solve a lot of performance issues through the use of patterns. One of the biggest bottlenecks is passing large chunks of data around, right? We all know that talking between the CPU to the GPU can be very, very slow and a very expensive task. So, well, hopefully DirectX and that will fix that. But what happens is when you're passing that data around, you're wasting all those cycles, right? And that's not something that we want to do, especially on lower memory devices. You know, you've got all these handhelds being sent out with less than 512. You got set-top boxes like, you know, PlayStation Television, Google, and Amazon Fire. These devices don't have large amounts of RAM, right? So you have to become very strategic about how you're using your memory and how you're allocating things. So here's the situation. We got a game where you slay thousands of goblins, wave after wave, right? The longer you stay alive, the more goblins attack you. Problem is, we hit a brick wall right off the bat. We're targeting the newest smartphone. You know, it's a little bit lower memory device, and we're finding after a few waves, we got no room. We're out of memory. Right? But so far, what we've been doing here is we're just creating goblins as we need them. We're saying, okay, I need another goblin, create a goblin, right? So if you think about it, this is how it would kind of look. We have all these goblins. Each one has a mesh, a texture, some sort of animations, maybe a position, a color, whatever it might be. If you look at this right off the bat, you'll notice that a lot of this stuff is common, right? So like the mesh that all these goblins are going to be using probably are going to be the same mesh, right? The textures are going to generally be the same. The animations, you know, if you're trying to cut corners, obviously they're going to be the same. Position color, those are the things that are probably going to change, right? So time for the flyweight pattern. So the flyweight pattern, as its name implies, is basically geared towards minimizing memory by allowing you to share as much data as possible with other objects. It's basically a way for us to use a large amount of objects without having to create new ones constantly. So to kind of visualize how this would work in memory, you'd have something like this. You'd have your shared model at the top, which is going to have your mesh, your textures, your animations. And then each one of these are going to have their own values, like for position and color, right? Those will be separate, but they'll all be calling back to the main model and asking for that mesh, the texture, and animation, right? So right off the bat, you can see how we're going to be saving ourselves a lot of memory because we're only going to load the mesh and the texture and the animations into memory once. Even if we create a billion goblins, those billion goblins are all going to be pointing back to that one location. So here's a little UML. Forgive me if this is wrong. I haven't used UML for a while and never used UML2 until this. Does people still use UML? One guy. Okay, so forgive me if this is wrong. But basically what we have here is how the flyweight's laid out. Basically there's the concept of intrinsic and extrinsic states, right? So we separate our data into these two types. The intrinsic state are for things that are constant and that we can store in memory. So in our case, it would be our animations, our textures, and meshes. As well as we have extrinsic states, which for things that are calculated on the fly that we necessarily don't want to stay in memory. So in our case, you know, position, color, stuff like that. So up at the top here, we have the flyweight factory. And factory is another pattern that I highly recommend you take a look at. It's very, very useful. And it's kind of cool because, like, going back to my Lego block example, you're able to plug patterns on top of each other to come up with some pretty cool stuff. So what we're doing here is we're using a factory class. That's basically just an indexer that allows us to retrieve whatever flyweight object we create using some sort of index pointer. Then we have the iFlyweight, which is an interface that defines the methods and properties required for using our flyweight objects. And then, of course, down here at the bottom, we have our concrete flyweight, which is the actual object itself, and it has a holder for intrinsic states, and then, of course, for its given extrinsic states as well. So this is what the UML would look like for our goblin example, right? So we have the goblin factory up at the top that basically stores and retrieves our goblins using a get goblin and save goblin. Then we have our interface, which basically tells us what we need in order to use those. And then from there, we have our large goblin and our small goblin, right? And each one might have a different style or a different color, whatever it might be. Well, actually, in this case, they're all sharing the same style, or every large goblin will share the same style, every small goblin will share the same style, but each one can have a different color. Now, a comparison between this flyweight pattern and prototype pattern can definitely be made. If you were looking at the UML side by side of these, they would look very, very similar. The major difference is the prototype pattern is used to create new objects that are basically similar in type to that object. So you would consider that to be a creational pattern, whereas the flyweight pattern is allowing us to use the same instance of one object in memory. So it's more of a structural pattern. So those are the two differences. But if you were to look at them side by side, you could kind of get confused because they are very, very similar. So what I'm going to do now is I'm going to actually show you some code because it's not a presentation by me unless there's code involved. So I'm going to just walk you. This is a very trivial example, but it kind of shows what I mean. So up here we just have an email for our color, nothing major there, just some stuff to print it out. But right here we have our factory class. Oh, it's not even on the screen. Jeez. Let me jump that over. Oh, there we go. Can we see that? Is that large enough? Okay. So up the top here we have our Goblin Factory class, and we created it. And then we're basically saying save a goblin, one large goblin and one little goblin. And we go down here a little bit after, and then we have our interface. So our interface just basically has our style and our get color, right? So our intrinsic state is our style. Our extrinsic state would be our get colors. And then we scroll down a little bit more. So here's our large goblin, the actual object itself. So it has its intrinsic state, which is its style, which is large. And then it also has, its return, so it returns the style that it's in, and then it has its get color. This is an extrinsic state, so this is one that can be different for every one of these, right? And then, of course, we have the same thing for little goblin. So I'm just going to fire this up and show you really quickly what happens here. So I know it's just really quick. It's a very, very toy example, but it just proved my point. So right off the bat, we create two goblin types. We create a large and a little, right? And we store that up in memory. So that's our mesh, our animation, all that stuff. That's stored in memory. And then what we do is we create the goblins based on that. So we create a goblin of type 0, which is large, and he's green. And then we have one that's red, right? And then we have a couple other goblins that are a different type of little, and they're red and blue as well. So what we've done here is we've created 4 objects calling back to 2, right? So we could create 70 little goblins, 80 big goblins, but the thing is, in memory, the big chunks of goblin are only 2 things. There are a little goblin and a big goblin. Does that all make sense so far? All right, I'll jump back into my slides here. Oh. Still trying to get used to the Windows 10 world. Okay, so basically you've seen there that, even I know that was a very toy demo, but hopefully it drove home my point, that using a class like using a factory class coupled with our flyweight pattern, we're able to alleviate a lot of the strain on our memory, right? So if we're creating a game where you have like a bunch of waves going on and you're running on a low memory device, this is one really easy way to be able to accomplish that task without overloading the memory. I'm sure there's a million different ways that you guys can implement that in web development and anything else. So I'm just going to keep moving on because I'm getting a little low on time here. The next thing I want to kind of talk about is what I like to refer to as the case of the singleton. So patterns are great tools, but they can also cause their own problems, right? Overuse or misuse of a pattern is a very easy thing to do. It's not too hard to fall into the rabbit hole and start worrying about, your structure more than the game or the program itself, right? It's very, very easy to do. One pattern that I think falls into this category is a pattern that I think everyone overuses, and that's the singleton pattern. Who used a singleton before? So quite a few. Okay, so I heard someone tell me a little while ago, and it's kind of stuck with me. Friends don't let friends create singletons. So what is a singleton? Well, a singleton is basically, it's a pattern that allows us to restrict the creation of an object to one instance, right? There's a generalization, but that's basically what it is. So if you take a look at it, again, I'm going to bust out my fancy UML here. Basically, you have an instance that's private, right? You have a public method that you can call to get that singleton. And then, of course, you have the singleton constructor itself that's private. So the code would look a little bit something like this. So you'd have, your read-only singleton, which would make sure that we're only going to have one of these, and then we'll have the private singleton, which is the actual constructor, and then our getter, right? This is a very, very simplistic way of doing it. There's many, many ways of implementing singleton, but this one is probably the most basic. So at the surface, it doesn't seem like that bad of a thing, right? Okay, it's going to stop me from creating more than one instance. Not a bad thing. Well, there's a couple of reasons why it's bad. First off is they aren't concurrency friendly, right? So if you implemented it like I implemented it there, or similar ways, it's not thread safe. You're going to run into issues where if one object is able to create it while the other object is looking at it, you're going to run into race conditions, deadlocks, a bunch of other really, really fun stuff that comes from playing around with threads. So that's one reason we don't want to use it. Another is it's globally available. So whether you like it or not, that instance of your singleton is available to your entire program. May not be a bad thing, but in some cases it is. It breaks tests. It just breaks tests. False positives, a lot of issues. I've seen guys spend more time writing hacks to get around their singleton for their tests than actually building a better pattern than a singleton. So definitely a lot of problems there. And it couples our code together, right? I just spent a bunch of time talking about how you want to decouple your code. Well, singleton just couples everything right back together, right? So it's one reason to stay away from it. And last, because there's a lot better ways to do things than a singleton. So I'm going to just talk a little bit about how you can replace the singleton, right? So a lot of times I see singletons, especially in the gaming world, used in managers, right? So I'll have like a game class. And okay, everything should know about my game class that needs to know about it, right? But if you're building a singleton class, think to yourself, is it just a manager? Is it doing is just holding this one single instance so that I know where it is and I can access it? If that's the case, you don't need a singleton. There's definitely ways to get around that. Just rewrite your code, make it a little bit more structured so that you don't have to have just this manager class to point to something. Do you really need to limit the class to a single instance? If the case is yes, try an assertion. Build an assertion function, right? Does the same thing. It's going to lock it down to only one instance, but you're not going to come with the overhead that comes with a singleton, right? It's not going to make it globally available. So do you need to provide access to everything, right? Does everything need to know about this instance? Chances are no, right? Even in my game class, I don't pass the game, or I don't give the game class access, or everything access to the game class. When I create something, or I need the game class in something, I pass it along, right? I just pass it on to that function and let it work with it, right? Simple way of doing it. Do you need to manage the lifetime of it? If you really need some way to manage it, take a look at like an IOC framework, which is a version of control framework. There's literally, I think when I checked online, 3.2 billion frameworks for IOC. And the majority are available as NuGet packets. Right? So if you really need some way to control this lifeline, the lifetime of your object, take a look at something like that. And of course, if the singleton is the answer to your question, just implement it properly. Take some time, go through it. Don't just implement it because it seemed like the easiest way to get through the problem that you're at, right? Take some time, think it through, because it will come back to bite you. I can pretty much guarantee that. Okay, so before I let you guys go and jump into any questions that you have, I want to give you guys some like extra learning material. So first of all, design patterns, absolutely great book. If you haven't read it, definitely pick it up. And get past the chapter of Singleton. Don't just read Singleton and skip it. I think that's what happens, and that's why everybody uses Singletons. And Code Complete. Check out Code Complete. The newest version is version 2. These are a little bit dated. I think Code Complete was 2004. So they are older books, but the principles inside of them are very important even today, right? So take some time, read through them more than once. I try to read through them at least once a year, and believe it or not, every time I go through it, I learn something new or catch myself doing something that I should have been doing. So definitely check that out. So I'm going to give, do we have enough time for some questions? Okay, good. So if you guys have any questions, don't be shy.
So nowadays, people are always doing something new patterns, like MVC and always exhausted. So how do we make about that?
Patterns are going to constantly evolve. There's going to be new patterns coming out daily, right? Like I said, you can take patterns and connect them together like Lego blocks. So you're going to find patterns that are going to evolve from other patterns. So I'm only going to learn these patterns that are in this book is not a good mentality, right? Like you constantly have to be evolving with them, and it's a good thing, right? As development shifts and we find new and greater ways to do things, the patterns should come along with them. So I'm a highly fan of anybody that comes up with a new pattern. Anything else? It's kind of bright stuff, isn't it, in the back? No? Because they're going to let me off so easy. Oh, here we go. Very nimble. I basically don't lock it down until we're going to gold, right? And until the day it's going out the door, I'm still tinkering with it. And like I said, when it comes to the case of the Singleton, right, you have to be careful because what happens is you get this mindset of, well, I like this pattern, and this pattern works so well for so many things, and you end up starting to build your project to fit the pattern, and not the pattern to fit the project. So you got to be very careful with that. Again, sit back and think it through. Do I really need this monolithic pattern, right, if I'm only doing something very, very small? Anti-patterns are just as good as patterns. Anybody else? Yes. Kind of. In a perfect world, yes. I try to do it as much as possible. Usually I use UML when I'm working in groups of people. If I'm working by myself, I kind of know the flow of my pattern, so I'm not too worried about it. But when it comes to when you're releasing your software to the world, you should probably have some sort of UML diagram to kind of explain it. But I know, like, by the judging it, when I ask how many people use UML, and they're like, I know it's a little bit of overhead, but I'll tell you one thing that Star UML, I know for sure, is you write all that UML out, and then you can spit out your stub code. So it's not like you're going to write the code twice, right? You write out your UML, you press a little button, it spits out some really nice stub code, saves you some time. Singleton. And probably in the gaming industry, the overuse of Singleton in game manager classes. Right? Everybody just automatically, like, I don't know how many times I've walked into a project and seen game class, game manager, input manager, system manager, screen manager, game over manager. I'm like, why so many managers? And every single one of them was a Singleton. And I'm like, why? So yeah, that's one is the one that just drives me nuts. So I stay up awake at night trying to deal with that. Anybody else? Yeah, that's the thing, right? Like, patterns try to stay agnostic to the language as much as possible, right? But what happens is when you start drilling down into a certain language, like if you're in ASP.NET or you're working with Java or you're working with JavaScript, whatever it might be, you have to start to tweak the patterns a little bit to play nicely with the framework that you're in, right? Because at the end of the day, if you think about it, ASP is literally just a bunch of patterns itself, right? So you have to kind of play nicely with how they've designed it. It can be a headache, but I've experienced it myself numerous times. Okay, so, oh. I'd say yes. Strustrup, the creator of C++, probably, I'm probably just going to paraphrase, I don't remember exactly what he said. He said, if ever you're using a Singleton, you're doing something wrong. There's a million and one ways to do what the Singleton's doing. And the chances you're just using a singleton because it creates one of something and it's global. That's usually why everyone's like, I'm going to use a singleton for this. So yeah, in the MVC situation, there is definitely better ways of doing it than just locking it down with singleton. But I find that a lot of people, when they're learning MVC, they're so concerned about the MVC part of it that they're just not worried about the other little tiny parts, like how should I properly set up my controller, right? How should I set up my viewer and things like that. Did I answer that one? Okay, so I'll let you guys go. One thing to note is we do have an MS Lounge out there. It's kind of out to the left. Yeah, we have stickers, and they're cool stickers. These are the stickers that everybody's kind of wanting lately. Right? So come by, chat with us. I'm going to be over there today between 4 and 5. Randy, a colleague of mine, who's hand up here in the front, he's going to be hanging around there tomorrow from 4 to 5, and then you're on there Tuesday again. So come chat with us, ask him any questions you want. Feel free to pick his brain. He's the web guy on the team, so he knows a lot about that stuff. So make sure you come chat with him. But thank you very much.